Today we are going to have a very special guest, someone that I hold dear to my heart because my team does a lot of ecosystem developer support, and sometimes it's awesome to find someone else within the company that shares the same kind of passion and sentiment for wanting to help out developers in the ecosystem. Today we have Andrei Yakolev, who's on our, he's a principal premier support engineer. So if you have a customer in a very high demand instance that complains about your app, sometimes it trickles down to our premium support organization, and a wizard like Andrei digs in really deep and helps out the developer fix those problems. He's originally from Ukraine, but he works out of our office in the Netherlands, in Amsterdam. So please, oh, and also it's his 4-year Atlassian anniversary. Congratulations on Monday. Woohoo! All right. Please welcome Andrei up to the stage.
Thank you. Hi, everybody. My name is Andrei. And today, I would like to talk about the relationship between Jira and apps, plugins, that's the old name. And it's a story behind those two big words, and it's a performance story. So I would share results of the research which we did, and for those who are listening to this talk in November, it's updated and extended talk, so it's more details. And I will show the results of research, I will share the buckets of the problems, and also I will try to give you a couple of practical takeaways, so when you go home you have something to think about, maybe even improve application and make it rock solid. And before we start talking about this, I would like to get back into this performance. What is performance and what is this about? And quick question, how many people believe they had performance problem in their life? Okay, all right, good. So I was thinking, what is performance problems? And I was, okay, it's a from one point, everybody understands what is this, and from another point of view, it was really tricky to understand what is performance problem. So I asked guys in my team, I had different answer. I was like, that's curious. Then I was Google a little bit, I get different answer again. That's curious. So I decided to get to the source. This is like ZOS, right? This is one of the oldest operating system which is there. And this is the quote from the documentation. And this is as vaguely as it can be. But at the same time, this is something which that capture my mind, and then this is something I'm thinking about, is that the key word here is pain. So performance somehow is a pain. And in a nutshell, we'll talk about the pain which is caused by the different performance problems in Jira, and at the end, the users behind the Jira, because code is a code, software is software, but at the end, there's the end users there. So what exactly we're going to talk about today? I'll try to explain and try to help convince you that this story is relevant, and it's relevant to you. I will tell you the story, and then I will give you practical examples of deep dive, how exactly it looks like. And it should take around 30, 35 minutes, and then I'm planning having 5 minutes at the end. If not, afterwards, you can talk to me after this talks. So why this topic overall appears, and then how you as vendors play a role into these discussions. So first of all, I would mention that problems which I'm going to talk about is mostly data center problems, because research was done mostly on data center, and for large enterprise clients. So it's a massive amount of end users sitting behind those instances in Jira. So when companies purchase data center, they purchase for mainly two reasons, right? They want stability and they want performance. And this is something they are referring to improve the availability of the instances. They want to make sure that the investments is actually long-term, is worthwhile. And that's a big promise. And unfortunately, in some cases, apps is not helping this to deliver this promise, right? And in those cases, when this promise is not there, customers usually talk to us, to Premier Support, It's a dedicated team, and it's a paid service, which large enterprises purchase to have a help, and we partner with them on their performance problems to make sure that the instances are stable, and then to make sure that they overcome those problems. And in some situation, it could be infrastructure discussion. In some situation, it could be discussion about some problems in the configuration. Sometimes it's just lack of scale. But in some cases, it gets to the code, the problems inside the code, problems inside the functionalities. And at this moment, we decided to categorize those problems, and we have inside the company, we have definition, and we have goal to make sure that we relieve this pain. And the key word for this pain is L1, L2, which is definition of the problem, and it's definition of tickets raised with support. And L1, L2 means application is down or serious performance degradation. That's a definition from support perspective. This is definition which we agree on with the clients. And we measure in this definition. We measure the number of those tickets. We measure the number of those pains, which is customers show us. And when we look back, we understood that we have multiple buckets of those, right? Unfortunately, application is a number of installations is quite high, so it's not like just single proportion, 80-20 or something. So it's a lot of small buckets around this. And for those problems in those buckets, which is L1, L2, very often that we have very high SLA. It's like 30 minutes, 2 hours to make sure that we resolve the problem, to make sure that we get to the bottom of this. So, and this part is where it's kind of relevant to you, is that 10% of those L1, L2s is related to apps. It's a quite high number. And this is exactly where you can help. Lowering down this pain, lowering down the amount of pain to much less. And numbers is good, right? Numbers is a nice way to quantify things, but at the same time, there's more than just the numbers. There's a story behind those stats. And it's hours spent on troubleshooting. From premier support perspective, it's our time. But it's also the time which is companies spending to troubleshoot with us, collect the data, analyze the data. And at the same time, it's multiple downtimes and multiple hours which end users spend, if you can say it in a nice way, with this problem. It's like a negative experience. And the last part here is more like outside it. If you think about this, all this massive amount of problems, massive downtimes, which might happen multiple times per day, they break very important part. They break relationship, and they ruin the confidence. And at a certain point, the Jira admin or end users might say, well, we don't want this app anymore. It costs too much trouble. Or, OK, hold on. We have this app. We stabilize ourselves. And then don't install more apps anymore, because we're tired to fight with what is going on. That means either problems with existing app, which is meaning like licenses not used, or it's a problem with not new apps installed. And this is two sides of this. So first of all, in some cases, user experience might be degraded. In some cases, it could be lost opportunities. I hope it's convenient enough that the problem is relevant. So we thought about, OK, so we know the numbers, but what makes those numbers? How you can make a bridge between these numbers and actual problems, so developers can look into those problems, they understand what is inside them, and actually make some actions, because this is numbers is good to convince people, maybe at a certain level, but then what's the next step? It's good, but what's the next step? So what we did the research. We deep dive in a lot of code. We partnered with a lot of vendors. How exactly the applications affect Jira performance and stability? And before we started this research, we said, OK, most probably we'll have 3 buckets. Like from my experience overall, there should be stability problems. Right? It's kind of definition of L1, L2. There should be performance problems, again, definition of L1, L2. And most probably there will be functionality problem, then something is not working to the point it's completely useless. And when we did this research, we understood that, well, functionality is not a problem, which is good. But the bad part is that performance is so big, so it's a 4 buckets, actually, sub-buckets. So it's a memory sub-bucket when the problem is such a pronounced problem that it's visible throughout of memory or massive GC. It's like area which is exactly visible inside the performance. Then another one is DB, and we'll talk about these buckets more in details. DB when related to the either overloading the database or on the edge of application and database. CPU, when it's a contention on CPU and CPU become a point when application doesn't work because of the CPU being stolen from different threads. And other, it's kind of catch-all bucket with everything, right? I was curious about proportion, and I would say that it's interesting to understand how it will be, right? And how many of you think that stability is the biggest bucket? Right? No? A couple of them, okay. How many of you think that if you get back, how many of you think memory is a problem, biggest problem in Jira? Okay, okay. I can clearly see that you have some experience. DB? Okay, good. I'm glad you're here. So this is the proportions for Jira. And memory is the biggest problem. And this is what I thought while we're doing this. But my surprise, this is something I didn't expect while working a lot with Jira, is that DB is actually such a big bucket. And then other and stability. And stability is not the biggest one, which is good, I think. At the same time, we did similar research for Confluence because we did it company-wide. And then we wanted to understand how the application behaves. Maybe it's a common problem for everything. Maybe it's a problem for Java, right? We're a Java shop at the end. Memory and Java, it doesn't very well, right? So this is the stats for Confluence. I'm not going to talk about Confluence today, but overall, just to have a perspective. And then it's different. Stability is the number one, CPU. And it's not about that something is better, something is worse. It's different apps, different history, different environment. But overall, it means that the problems for Jira is not, it's kind of unique, but not unique at the same time. Right? So more deep dive about these buckets. And then what exactly makes those buckets? So we know the biggest one is memory, but what are other buckets? What contributes to these problems? Specific examples about those. So stability when application doesn't start at all, or it's running, but it's basically useless. And one example of the application doesn't start is the P1 plugin. It's an old version of plugin. Usually it's relevant for the in-house development plugins. Like all the plugins these days are P2 plugins. When they polluting class loader, and then basically it has a problem with defining proper definition of the core functions, and the application doesn't start. In this case, it didn't start because of UPN problems. Another more common example is Jira stalls it all, like it doesn't return any useful data. And a couple of possible areas here is corruption of important Jira tables due to the either direct access to the tables or abusing or misusing the API. And the Jira can't correlate and can't recover itself from this situation. It's become null pointer exception at a certain point. Or corruption of the cache, when the cache becomes poisoned with bad data. Another one which most probably everybody has, I had it, the recursion. Right? And then recursion leads to Stack Overflow problems. With Stack Overflow, it's interesting. Normally, you think, OK, Stack Overflow is something which only this thread will care. It will be killed, and that's it. We'll move on. In some cases, Stack Overflow is part of the critical function, like cache population in the critical code, or the BCP operations will lead to corruption of the internal memory structures. So basically, Stack Overflow in the frames will lead to the situation then this part of the functionality is useless. And that leads with Jira with being completely unusable. You need to restart. And the last part is more like a dynamic problem, exception in main execution flow. like during the page rendering, something like this. Then when there's a filter or some core functionality, and then exception in this code prevents the whole page rendering from happening. What's interesting about stability problem is that most of them quite well described as the bugs. It's the production steps. You can have a staging environments. You can reduce the problem there easily, quite easily, with the configuration of Jira. So those problems are kind of easy to understand. They are there. You try it again and again and again. It's still there. The performance problems contrary to that. Usually it doesn't exist when you have a single user on the instance. Maybe depends on the configuration. So those buckets are different. That's why they require different technique. So here the example of the performance problem, which is other bucket, is that slow application. It was caused by the large number of cache flush events, especially in the data center environment. When you do cache flush events, this cache flush happens across the whole cluster. Basically, at a certain point in time, your whole cluster is not responsive. And if you have a lot of them, it responds quite a lot of time. Jira provides you a couple of granularity, what kind of cache flush events you can do. And in that case, the plugin was doing the flush all, which is quite coarse cache. It's not a cache, it's a meta flush event. So it flushes everything. So the mitigation could be either prevent cache flush if you don't need it, or just use that specific cache if you actually need it. Another example is excessive logs in specific code, which is dependent to the functionality. It could be that specific part of the gadget, a specific part of configuration, which uses the code, uses its own logs. And this is where Jira becomes dependent on this part of the code because of the excessive logging. And the last example is, I would say, a little bit tricky. Here, because of the creating and parsing a lot of XML, Java code creates a lot of SAX parsers, quite behind the scenes. Those parsers need to be properly created and allocated by JVM, and it becomes contention point in class loader. So it's quite deep inside the JVM. But since it's a contention point in a class loader, it's become contention for other parts of the Jira, because sometimes Jira needs to load the classes for other operations. For example, for execute the OSGI or going through these proxy abstractions. So this is when one part of application affects another part of application quite deeply inside the JVM, something which you would normally not expect. And without load, this is not reproducible. You need a lot of load for that, because this is bottleneck deep inside the JVM. Kind of, sometimes it could be as hard as that. DB problems. Here, usually they are around active objects, and the typical problem here is that active objects as a tables become big, and they don't have indexes. Obvious answer is that delete the data if you don't need it, do housekeeping jobs, and also you can use annotations for classes, and you can create indexes for the tables. Don't create all possible indexes because they're expensive, but at least create indexes where it's necessary. And those queries with proper indexes, then it will be fast. Normal situation, you have like 5 million rows, and you query the table without like simple ID, without index, and then this is where it becomes a problem. Kind of edge case situation when plugin abuses the API. It's a valid API, which goes to database, but abusing this API causes the problem in database. Kind of hammering the database for this. And the last one is on the edge between the application, between the Jira and the DB. And it's when the DBCP pool inside the application is basically become clogged. You can't take the allocate application. This is when the plugin, and this is another point similar to the discussion which we had with JVM, is that the bottleneck in one part become bottleneck for the whole application just because somebody abuses this. It's a common resource. And being not a good citizen, this is when everybody struggles. And then here it could be as a side effect of slow queries. So there's not a problem overall, but since the query is a little bit slow, they take a little bit longer time in the pool, and the pool become populated. Right? In some cases, you can just increase the pool size to overcome this problem, but it's not always welcome. More typical problem is here to have multiple connections per transactions. And this is where you basically have 2 or 3 connections per user actions, and then you have many user actions, you just allocate all the connection from the pool, and that's it. And here, tuning the connection pool doesn't help that much. So good practice is that don't use multiple connections. Just have one connection. And the last, more like a side effect of another problem, is that it's a dog pile of caches when cache population doesn't happen in a single thread within the app. And all these threads go to database to allocate the data. It's kind of valid connections, valid code, not reproducible in single request. And then you have 30 connections going to the same database for same request, and then suddenly this DBCP is out. And then there's a problem. And last bucket is the biggest one, as we know. It's a memory. And it has 4 pronounced problems related to GQL, related to out of memory for large data sets, related to leaks in thread locals, and excessive memory churn. And to this point, I would say that we really need to go deeper with more examples. Because this is the biggest bucket, and since it's the biggest bucket, I believe we can do the most impact on this area. And that's something I think having more details here will help. And before we move on is that, how many of you had experience with one of those specific GQL problems, specifically GQL with Jira, when you have out of memory because of GQL? Awesome, cool. In most cases, there is easy win. So one of the typical problems, one of the typical problems with out of memory for GQL will be because of the asking too much data from the scene. And here it's a function of size. If you have small instances, it's not a problem. If you have a big instance, this is immediately when things become really hairy. And the typical approach is that we ask in Lucene, please give me the data. We do search, and then at this point in time, Lucene is out of memory because it's 3 million, 5 million issues. The easiest approach is that use max result. Don't ask everything in one go, use specific pagination. That will be the easiest one. In a lot of cases, there's even better approach, and we'll touch this a little bit later from another angle, is that you can use issue collector to collect results which you need by asking Lucene doing this for you. Very often, you don't need all results set. Very often, you just need the issue ID, for example, or you need maybe assignee, some couple of fields, like up to 5. And in this case, you can just allocate this job to Lucene. Lucene will do it for you and just get back the results. That means you don't need to load all these objects into the memory, and that means less memory usage. We work with the vendor on this, and then they posted the community on the dev forum. And I really advise you to read this. It's a very good post with more details, more examples, the snippets of the code. Practical, you can copy paste and start using it right away. This is a recent post from our team working on Lucene upgrade on the same subject with a little bit more details, how you can use Lucene optimized way in Jira 8, because in Jira 8 we upgraded Lucene, and some of the things there also changed. So again, please go to dev community and check it out, the recent post there about Lucene. Problem for dataset, it's kind of obvious. I believe everybody knows this, but I just wanted to mention it because, first of all, it's a problem. Second one is that for the sake of having the holistic overview of this is that it's too much data processed. And the obvious answer is that don't process too much. So use streaming API, use pagination to make sure that you control amount of memory which you allocate. In cases of when you accept the user request, make sure that you do also pagination on this. And the biggest task is test on large data sets, like 500,000 issue, 1 million issue, big requests, big reports. This is where it's easy to reproduce the problem. This is when it's easy to capture the problem while you're testing. The next one is interesting. It's out of memory, which doesn't happen right away. It might take you a week, sometimes 2, sometimes 3 weeks. It's a dribbling effect. The data is slowly, slowly, slowly accumulated in thread locals or in some caches in Jira. Clearly, it takes a lot of time to reproduce this problem. Or you need to, if you know how exactly it's created, then it's easier, but normally in live instances, it takes a couple of weeks. And if you see the GC logs, it will be slowly going in the underlying trend. And these are a couple of possible situations. In some cases, the Jira authentication context, it's a side cache which Jira creates for you to make sure that it provides you good performance. It's kind of companion which is always there for you. And in some situations, when you have very long-running threads with batch processing, this cache accumulates the results because it thinks that you're going to reuse the results. It kind of assumes that you might, if you just did something a second ago, you might just do it again. It's a good assumption for user actions. Because very often when you do something loading, you will load the same username multiple times. But if you do clearly batch processing, which is not true, you know that you will touch the issue once and that's it. You will move on. And this is where you might accumulate a lot of results set there, especially if you do it inside your own threads without properly cleaning those result set. And these are more examples I'll share with you. And another one is that thread locals and then no finals for thread locals. And then basically, in this case, if you have some exceptions or something, then those thread locals are lingering around. And if those thread locals are part of the long-running pool of threads, which will be HTTP pool from Tomcat, which is user-initiated sessions, this is where those thread locals might stay forever until somebody starts them. Kind of obvious answer would be always clean thread locals. Make sure you test them, make sure that you don't forget about removing them, especially if you're assuming that these are the batch jobs, threads which you create for long running, maybe weeks or like a couple of weeks, or it's a threads which part of the user sessions, HTTP context, because those threads will stay long. And you can't control life cycle of them. Tomcat controls them. What you can do is your tests. You can run soak tests, maybe 8 hours, 1 day, depends on your data sets. So usually after this time, you might see some trends, and you might see some patterns there. And what you can do, you can collect the heap dumps before and after the test, and then check if you see some memory structures which you have no idea where it's coming from, and they're growing. That could be a good example, and this is exactly how we capture the problem normally during the analysis. And you can refer to this ticket. This is a good example of this problem explanation, so you can follow up on this with this performance bugs. That's a Jira Atlassian.com ticket, just in case. Last one is, I think this is the hardest one and most kickiest one. It's a lot of FullGC due to excessive memory churn. And I'll step back for a second and explain the context. What is this? So since allocation in Java done through the heap and it's not direct allocation, then Java will need to clean this memory at some point. So when Java can't clean this memory concurrently anymore, JVM will say, whoa, whoa, guys, too much, pull back. And it creates the stop the world. Everything freezes. $10 seconds, maybe 20 seconds. And sometimes this freezes happens 10 times in a row, so back to back. So 10 seconds multiply 10, it will be a couple of minutes of complete downtime of application, which perceived as downtime, and it's true downtime for end users. Here, the problem also is that it's quite intertwined. One part of this is that these memory allocations might happen in different places. It could be way below the abstraction level which you're working on. Sometimes it's your code, sometimes it's even like multiple level down. It's one problem. It's one dimension of this. Another one is that these memory allocations, if you test them on the lightly loaded instance and you have good JVM settings, they will be allocated in the area which is called new gen. And garbage collection in this area is super cheap. It's milliseconds. The moment when those objects are moved to old gen, this is where the problem is. And that means it's reproducible under load only. or mostly under load. And the last part is that the behavior of the JVM itself, GC behavior. It depends on the configuration of JVM, which might be different per customers. Depends on other configuration running there, other apps running there, how much at this specific moment in time somebody created the report, which will take 4 GB of memory. So it might be also floating with this configuration. So all this intertwined. But at the end, it's when so much garbage is produced inside the JVM that JVM will say, it's enough. I can't hold this anymore. Pull back. So to give a couple of examples, practical problems, it's millions of score docs allocation for large scenes when hit queue is used. And in this case, it's kind of behind the scenes. You use the hit queue in not very optimal way, and this hit queue search by Apache, Lucene itself, produces so much score docs that it's basically become too much for JVM. That's one example. Another example is that XML Beansly presentation of the document cells and processing large document cells by abstracting those releases the millions of objects of these XML elements. This is where they become a problem. The advices for these areas is harder because the problem is overall hard. So I would say generic one, maybe it's too generic, is that if it's your code, try to reuse objects. Don't just produce garbage. Try to see if you can reuse objects, if it's possible. Or maybe know the API behind this and change the API. Like in this example with the hit queue, using the hit queue was not a good API to solve the business task. It's better to switch to something else. And that something was basically produces less garbage. Sometimes it's just ask for less data because data is produced, by producing this data, you produce this garbage also. So having less data sets which you work on, not a test data sets, but less data sets which you ask, will have a less garbage as a side effect. And the last one, which is similar to the previous one, do load tests. And here your friend will be GC logs, because it's hard to use the heap dumps for those kind of problems. It's usually better to use memory profilers. And you can use memory profiler from Java 11, which is become free right now. In Java 8, it was paid, but you can still use it for tests. So GC logs will help to have a profile between the data, and also at the same time, measuring the response time plus GC will get extra dimension to the problem. If you see that between releases response time is the same, but GC increased twice, there's most probably something going on with JVM. It's quite a lot of details, I understand. I feel that might be overloaded. So takeaways. As summarized and recap what we discussed today. So then I would like you to be aware that apps is affecting the application stability and affecting Jira stability. And it's 10% for DC. Memory usage is the biggest one. I would say addressing the memory usage will have the biggest effect on the stability, and it will really move the needle there. And I really encourage you to avoid the problem. Please use proper APIs, which is adjusted for your business needs, and test at large scale. We had a testing framework, which is GPT, Jira Performance Toolkit. It provides large data set, so you can use it as a starting point. If you want, you can use also GPT as the testing platform if it suits your need. With that, we have like around 5 minutes for questions. Well,
thanks, Andrei. Thank you. At the last point you just made was about a tool called JPT, Jira Performance Testing, and it's a tool that we use internally to do some, I don't know, some performance testing for the data center team uses it. And I think if you go to go.atlassian.com/JPT, you can find it. It's an internal tool, so your mileage may vary, but you can go to community.developer.atlassian.com and ask questions if you have any on how to use it. I have one question I'm going to lead off with. How often do you run into apps that independently they run fine, but the moment that they start, like the customer installs a second app and then stuff just goes to hell? Do you run into that? And how do you debug those kinds of issues?
Yeah, I don't have numbers for that, but I would say it happens, especially related to the memory problems. When each of the app isolated works fine, when they have this anti-synergy, I would say. And usually things, you start with the troubleshooting, you see there's too much moving parts, and if it's possible, you start just peeling this layer by layer.
Okay.
And it could be painful because peeling something which works right now and very used at this specific moment, it's really hard to say for 20,000 users don't use app A.
Sure. And one more thing, I don't want to hog it, but are there any special tools that you guys use, like any kind of commercial tools to help debug these issues, or do you just kind of use stock?
Yeah, so we used Oracle, how it's called? I forgot the name. And then a JProfiler, which is very useful for troubleshooting those. Plus, we don't use it internally since it's on-prem, so it's either AppDynamics or Dynatrace to collect these traces from the client itself.
Okay.
So this kind of tools is useful. There is a nice heap dump parser, which is part of the Gmap, so which is also fine. And I would say a couple of tools which we wrote internally to parse the thread dumps to understand the problem related to the contentions.
Okay.
So most of these tools are either available for free or you can just buy them.
Okay. Any questions for Andre? Awesome.
How does the new data center approval process help mitigate these app-related performance issues?
It's an awesome question. It's an awesome question. So, I remember the name of the Java app, just recall it, Flight Recorder. So regarding the app approval, there's two parts of that. First of all, encouraging vendors to test on larger data set. There's a question there about tests, building awareness. That's a first good part. Second part is that encouraging you to run these tests. It's another good part. So collecting those two details is a first start, and we're working right now to understand how we can improve further to make sure that we have more details. Maybe we can do more than just one talks a while, have a more regular discussions, which apps affecting the application, how, and having more like a stream of data flowing to you.
I can't provide specific numbers, probably because I just don't know them, but I do know anecdotally, just through team conversations, that it has improved. So for those that don't know, I mean, a data center app, you can install a server app on a data center, right? But it doesn't necessarily mean that it's going to perform in a high demand environment and across a clustered environment very well. And so if you go to developer.atlassian.com and you go and find the data center documentation, you'll see some best practices and guides that talk about these things. But we definitely have responded to the customers that have been complaining about, well, this app is not data center ready. I mean, even though it says it is. So we've put a program around it to ask the vendors to do some very specific tests to make sure that their apps are working well. Any other questions? Yeah.
We've been using some of the app which was data center approved before before the change, right? Last year you made those changes, and after that, all of a sudden the plugin or the app became data center,
Approved?
Not approved for not approved for data center. So so we have to take off from the suite to make sure that our instance is working properly. And we've been contacting with Atlassian to make sure that it's when this app would be data center approved. So is there any process, the timeline from approval?
Sorry, I don't have context on approval itself, so.
I can speak a little bit to that. So, I mean, it's kind of a multi-step process. I mean, the vendor themselves will have to go and enter the process, and if, whether or not they've done that, we can find out. But also, I mean, when you were using the server app on your data center, were you having performance issues, or is it just kind of more of a company policy that because it doesn't have a badge on it, we better not install it? Okay, got it. Yeah. but let's take it offline. So part of my team's function is around not necessarily data center app approvals, but just app approvals in general, right? So we can talk about that. Any other questions before we let Andre go?
A little bit over time.
Oh, that's right, yeah.
Yeah.
Well, thank you very
Thanks
much, Andre.
everybody.
Good job.